Hallo und herzlich willkommen.
Welcome to our How to Do video series for nexy, the wireless sensor network solution. My name is Jens Lindemeyer from Steute Technologies. In today's video, we deal with the setup and configuration of various interfaces, e.g. notifications or REST API. For this, we go back to my computer. To access the sensor bridge interface configuration, we once again log into the system and then click up here on the tab Notifications. Upon delivery, there are no configured notifications. For demonstration purposes, I will configure a test notification and simply call it test. A destination address must be given. That is the address to which the notification should be sent. This is usually an IP address. I will take a made-up IP address 123.456.12.12. I can then select whether the notification should be transmitted via the normal HTTP protocol or via the encrypted HTTPS protocol. I then confirm by clicking Save and have created a new notification. Now the notification can be configured. In other words, to which groups is this notification relevant? In the previous video, we assigned sensors to groups, and in this video we will see how different notifications can be sent to different groups. The standard setting is that a notification is relevant to all groups. But to change this, we can click on the plus symbol and select a group which should receive the notification. In this case, we shall select line 1 eKanban, which is now activated, and once again we confirm by clicking on Save. There are also some additional functions. For example, wake-up signals can be filtered out so that wake-ups are not sent as notifications, only actual switching events. Or I can set the 0 or off signal not to be sent as a notification. For eKanban applications, this is not such an interesting feature, but for end-on applications it can be very interesting, because then I often have a simple push button and do not need to know button pressed, button not pressed each time, but only button pressed. The notification has now been created and saved, which means that every time a sensor within the group line 1 eKanban is actuated, an HTTP notification will be transmitted to the destination address. If multiple destination addresses are being used, for example one destination address for an eKanban application, another destination address for an end-on application or an AGV application, then a separate notification can be created for each application as required, and a separate destination address is selected. The protocol transmitted via the HTTP interface looks like this. This is a sample protocol which contains all the relevant information. The structure of the protocol is always the same, always telling me which actor was actuated, what type of sensor it was, what is the current state of the actor, was it a normal switching event or was it a wake-up, which group does this sensor belong to, which parameters are configured for that group, i.e. description, parameter 1, parameter 2, what is the battery level, what is the signal strength of the sensor, as well as additional information such as how often has the sensor been actuated to date, what is the message type. If the message included a warning, I can also see what that warning was. The last point is this timestamp, meaning that the system clocks each switching event so that I can see precisely when it occurred. Here it is of course important that the configuration of the sensor bridge includes an NTP server, as already shown in a previous video. Otherwise, the timestamping information will not be precise. The timestamp is always the time currently set in the sensor bridge software. Our sensor bridge software has two more interfaces. They can be accessed by clicking on this little arrow here and then selecting the desired interface. Here we have our HTTP notifications, which we have just been looking at. Then we have our Modbus TCP interface, and we have a REST API interface. The most commonly used interfaces are a combination of notifications and REST API, which function slightly differently from one another. Notifications are transmitted as soon as events occur to the destination address. The REST API functions another way. The REST API is a typical API. In other words, something must be actively requested. For example, the superordinate system might query the switching state of the sensor 005E35, and the sensor bridge software would then respond with the current state of the sensor, as well as all other information assigned to this sensor. Configuration is not necessary because the system requesting information about a sensor must first log into our system using the appropriate login data and is then permitted to request sensor data. A list of all the possible queries which can be sent is available in the system, but also in our online documentation. The third interface of our system is the Modbus TCP interface. The Modbus TCP interface is usually used in order to control wireless actors. That means to switch on or off the individual relays of our sensors, to open or close them. The configuration is via this plus symbol. I click on it and must then select which relay should be switched. Thank you for watching. If you have any further questions, please do not hesitate to contact us directly. Otherwise, until the next video, and see you then.